For thousands of years, almost 10,000 years, human life followed a simple, natural rhythm. People woke up with the sun and worked according to the seasons. They planted and harvested crops when the time was right, and they built their lives around the natural world. Tools were simple and acted as extensions of the human body. The most powerful forces humans could use were the strength of a horse, the flow of a river, or the direction of the wind. If we look at the life of a merchant in 1700, it was very similar to the life of a merchant in ancient Rome. People made everything by hand. Goods were local, small in quantity, and limited. Life moved slowly, and nothing could be produced on a very large scale. But everything began to change in the late 18th century. In Great Britain, a country with wet, mineral-rich lands, humans discovered ways to use power from the earth itself. This power was not just a little stronger, it could be scaled up to do work far beyond what humans or animals could do. This moment in history is called the Industrial Revolution. The Industrial Revolution began around 1760 in Great Britain and eventually spread to Europe and the United States. It was the turning point when humans moved from making things entirely by hand to making them with machines. For the first time, people learned how to unlock energy that had been stored for millions of years and use it to build a completely new kind of society. In the mid-1700s, Great Britain was the most advanced commercial nation in the world. It controlled a vast empire, with colonies in the Caribbean and the Indian subcontinent. Britain was full of merchants, business people, and thinkers, but the most important thing was coal. Britain had huge amounts of coal, and this resource, combined with a strong spirit of invention and entrepreneurship, would ignite a transformation that changed the entire world. To understand why Britain led the Industrial Revolution, we can look at 5 key factors. Agriculture. Britain had already improved farming. New tools like mechanical seed drills and iron plows helped farmers grow more food with fewer workers. This meant many people were free to leave farms and work in towns or factories. Political stability and laws. Britain had a stable government and a legal system that protected property rights. People could start businesses with confidence, knowing their inventions and companies were safe from unfair seizure. Geography. Britain was an island with long coastlines and many rivers. This made transportation of goods easier than in many other countries. Science and innovation. The scientific revolution had created a culture of discovery. People were curious, experimented, and invented new tools and machines. Economics. Wages were high for workers, but coal was cheap. This made it very profitable to invent machines that could do the work of many humans. Before factories, most work was done in homes in small villages. Families followed the putting-out system. Women spun wool or cotton into yarn, and men wove the yarn into cloth using hand looms. It was slow work, but people made a living this way. However, demand for textiles, especially cotton, was growing rapidly. Initially, Britain could not compete with Indian cotton. Indian cloth was delicate, high quality, and much cheaper than British hand-woven fabrics. The British government even passed laws called the Calico Acts to protect local textile production from Indian imports. But instead of stopping trade, these laws pushed British inventors to find new ways to produce cotton cloth faster and cheaper. The first big invention came in 1733 when John Kay invented the flying shuttle. This small device doubled the speed of a weaver, but created a new problem. There wasn't enough yarn to supply the faster looms. It took 8 spinners to supply 1 weaver. Then James Hargreaves invented the spinning jenny, a machine that allowed 1 worker to spin many threads at once. It was still small enough to use at home, but was a first step toward factory production. Later, Samuel Crompton combined the spinning jenny and the water frame into the spinning mule, producing threads stronger and finer than anything hand-spun. The results were astonishing. In 1750, Britain imported 2.5 million pounds of cotton. By 1850, it imported 588 million pounds. Cities like Manchester transformed. Once a small town, it became Cottonopolis, a city of 900 factories. Smoke from coal darkened the sky, and thousands of spindles filled the air with a constant hum. But this progress came at a cost. British machines eventually undercut Indian artisans, destroying their industry and leaving millions unemployed. The textile revolution created wealth in Britain, but caused suffering elsewhere. While factories churned above ground, another revolution was happening below. Mines digging coal deeper faced flooding problems. Traditional pumps were too weak. This led to the creation of the steam engine. Thomas Newcomen built the first successful piston steam engine, large machines that pumped water out of mines. They were inefficient, but cheap coal made this acceptable. The breakthrough came when James Watt improved Newcomen's design, stopping energy waste and making steam power much more effective. This innovation allowed humans to use energy in ways never imagined before and powered the continuing Industrial Revolution. Matthew Boulton Watt, a business partner of James Watt, perfected an engine that used a separate condenser. This may sound like a small detail, but it was revolutionary. By making this single change, the engine became much more efficient. It used far less coal than the older machines. When Watt's engine was fully developed into a rotative type, it could directly power factory machinery. For the first time in human history, people were no longer dependent on the wind, the tides, rivers, or the strength of animals. Factories could now be built anywhere, not just near flowing water. Steam power was applied to almost everything. It pumped air into blast furnaces, hammered iron into shape, and powered the spinning and weaving looms in textile factories. Year by year, this invisible army of mechanical workers grew, producing thousands of horsepower without fatigue, feeding the needs of a rapidly industrializing society. Steam also transformed the iron industry. For centuries, iron had been smelted using charcoal made from wood, which limited how much iron could be produced. But earlier breakthroughs had shown that coke, a purified form of coal, could fuel blast furnaces instead of charcoal. This allowed for much larger furnaces and greatly increased production. Cast iron became cheaper, stronger, and widely available. A famous example is the Iron Bridge, which symbolized that a new material was changing the world. New manufacturing methods, such as puddling and rolling, made structural iron more affordable. Puddling, however, was grueling, dangerous work. Many laborers did not live past their 40s. Yet their efforts built the bridges, factories, and eventually the railways that connected cities and nations. The growth of factories also transformed Britain's cities. This period saw massive urbanization. In 1800, only about 3% of the world's population lived in cities. By the end of the century, this number had grown to nearly 50%. People left the countryside, often forced out by the enclosure of common lands, and moved to cities in search of steady work in mills and factories. Manchester became the model city of this transformation. Its population grew from 10,000 in 1717 to over 2.3 million by the early 20th century. Rapid urban growth, however, brought chaos. Housing could not keep up with the flood of workers. Families were squeezed into overcrowded slums with dirt floors, little ventilation, and no proper sanitation. Friedrich Engels, a social observer, described the streets of Manchester as a stony desert, with rivers turned green from chemical waste and raw sewage. Clean water was scarce, and diseases like cholera and typhoid were common. Life expectancy in these industrial centers dropped dramatically, and in some neighborhoods, more than half of all children died before the age of 5.
Inside the factories, work became even harsher. Unlike rural life, which followed the sun and seasons, factory life followed the clock. Shifts lasted 12 to 14 hours a day, 6 days a week. Most early textile workers were women and children. Child labor was not new, but factories made it far more intense and visible. Children as young as 8 worked as scavengers, crawling under moving machinery to collect loose cotton or fix broken threads. They earned only a fraction of an adult's wage, sometimes just 10%, and were often preferred because they were small and easier to control. The social challenges led to the first general laws against child labor, known as the Factory Acts. These laws gradually limited working hours and began moving children from factory floors into classrooms. Despite these hardships, the Industrial Revolution also created a new middle class. For the first time, businessmen, clerks, foremen, and engineers could enjoy comfortable homes with carpets, mirrors, and modern conveniences. They were the pioneers of a consumer revolution, where items like sugar, tea, coffee, and fine Wedgwood china became available to a growing urban elite. As production increased, old transportation systems, muddy roads, and slow river barges could no longer keep up. New infrastructure was essential. Canals were built first. Projects like the Bridgewater Canal showed that transporting coal by water was far more efficient than land. Coal prices in cities fell dramatically, inspiring a period called Canal Mania. Horses could pull barges carrying tens of times more weight than carts, making trade much faster and cheaper. Soon, canals were surpassed by railways. Railways were made possible by 3 critical innovations: cheap puddled iron for the tracks, the rolling mill to shape the rails, and the high-pressure steam engine. Inventors such as Richard Trevith and George Stephenson realized that if a steam engine could run on iron rails, it could move massive loads at unprecedented speeds. The first intercity railway connecting Liverpool and Manchester was a sensation. Passengers could travel between cities in hours instead of days. Railways also spread ideas, connected industrial towns to ports, and created countless new jobs. Steam power transformed the oceans as well. While sailing ships had been improved, steamships freed global trade from the whims of the wind. Merchants could track goods more precisely, and global commerce accelerated. The world began to shrink. Distances that had once taken weeks could now be crossed in days or even hours. Steam engines had not only powered factories, but had changed the very rhythm of human life across the planet. For many decades, Britain tried to keep its industrial secrets hidden. Laws were passed to stop skilled workers from leaving the country and to prevent the export of machines. But these efforts could not contain the fire of innovation. British entrepreneurs were eager to expand, and other nations were desperate to catch up.
Belgium was the second country to industrialize, thanks to rich coal deposits in the region of Wallonia. The transformation there was rapid. English engineers moved in and built huge factories that managed every stage of production, from raw materials to finished steam engines. By the mid-19th century, the industrial valleys of Belgium looked very similar to northern England. In France, industrialization happened more slowly. There wasn't a single dramatic takeoff. Instead, factories and new technologies gradually spread across the country during the 18th and 19th centuries. Germany, however, faced a different situation. Divided into many small states, it lacked a unified market at first. But the construction of railways changed everything. Railways connected cities, creating huge demand for steel. By the time Germany unified, the Ruhr Valley had become a center of heavy industry, eventually leading the world in chemical production and research. Across the Atlantic, the United States developed its own approach to industrialization. At first, it focused on natural resources, but skilled workers who had memorized the designs of British machines helped the country innovate. The Americans introduced the American system of manufacturing, which used interchangeable parts. Machines could produce identical metal pieces, allowing mass production on a scale never seen before. Even Japan in the Far East deliberately chose to modernize. After the Meiji Restoration, the government built railways, improved roads, and created model steel and textile factories. Thousands of students were sent abroad to study modern science and technology. By the end of the century, Japan had transformed from a feudal society into a modern industrial power. Not everyone welcomed this new era. Many skilled workers suffered greatly. Weavers and craftsmen who had spent years mastering their trade suddenly could not compete with machines. This despair led to the Luddite movement, where workers broke into factories and destroyed machinery. In the countryside, farmers destroyed threshing machines that made their labor redundant. These were the cries of an old world dying. Out of this struggle, workers began to organize. Trade unions emerged, teaching people that while one person had little power, a group of workers could halt production. Over time, unions gained the right to strike, improving wages and working conditions. The Industrial Revolution also inspired debates among thinkers. Karl Marx visited Manchester and saw a system he believed exploited workers, which he thought would eventually transform society. At the same time, Romantic poets and artists mourned the destruction of nature and traditional life. They valued the human spirit over the relentless power of machines. Even the environment began to fight back. Smoke from factories polluted the air, rivers became contaminated, and towns were filled with the stench of industrial waste. Early environmental awareness led to laws regulating pollution and building modern sewage systems to divert waste from rivers. By the mid-19th century, the first industrial revolution had matured, but a second wave was already on the horizon, one defined by steel, chemicals, electricity, and petroleum. The Bessemer process allowed steel to be mass-produced. Steel was stronger, more flexible than iron, and could build skyscrapers and massive factories. Petroleum replaced coal in some areas, and the internal combustion engine paved the way for automobiles. Electricity brought a new kind of magic. Gas lighting, which had allowed factories to work late, was replaced by electric grids, powering cities around the clock. This era gave birth to mass consumption. Grand department stores offered countless goods, turning shopping into a cultural activity. The telegraph connected the world, and literature for the masses spread like never before. Looking back, the Industrial Revolution was the most important event since agriculture was invented. It created sustained growth, increased income, and allowed populations in the West to rise steadily. But it also created enormous economic and social divides and shifted the world's center of power from east to west. Quiet green fields were replaced by cities with iron roads, railways, and factories. The legacy of the 18th century is still with us. The first spark of coal-fired energy fundamentally changed human life. It shifted people from following the slow rhythm of the seasons to demanding that the world move at machine speed. We now live with boundless convenience and breathtaking speed, but also carry the environmental and social shadows left behind. The Industrial Revolution began as a solution, but it changed more than anyone intended. Revolutions often arrive quietly, and by the time we notice them, life without them seems impossible. I am Tanvir, watching the past so we can understand the present. Together, we keep history alive, learning from it, and stepping into the next era. I see you there.